Coming to the floor plan, there are some terms and terminologies: utilization, manufacturing grade, and standard cell site rows and standard cell rows. These are basic terminologies. We can go through that. Utilization is nothing but the area occupied, and the manufacturing rate is the smallest unit that fabrication unit will give us, smallest geometry in that semiconductor industry. The it depends upon the technology what we are developing. So standard cell site is a unit type cell placement. So the smallest cell in the standard cell is a unit type cell, we say it as rows. Standard cell rows. The standard cell rows are nothing but we divide the floor plan into horizontal rows to place the standard cells which are of equal heights. So the width is depends upon the standard cell width. Placement grid. uh, Grid is made up of standard cell site. Like grids are the horizontal grids. We used to have vertical grids, multiples of manufacturing grids. So it is a multiple. So if I had a one grid, right, let us take the example. So this is my one of the block. So in that block, these are horizontal grids, vertical grids. So this is the smallest grid which we had. So placement grid is the multiple of all these grids. So this is the smallest grid, and 1 2 3 4 5. So this is the placement grid. Okay, row we say it as. So we combinedly say it as a placement grid. In this place itself we used to place the standard cells, right? Here one cell, here one cell, here one cell. We can use one or more than cells also. If my cell is taking two grids, two manufacturing grids, then it's not an issue. It depends upon the cell area. Routing grid, routing track is nothing but we used to place the based on that only we are drawing the metal layers. M1 metal layer, M2, M3, M4, like that we used to do. And flyline is the virtual connections between the macros. So we don't in floor plan we don't place the macros, right? We are not done with routing. So these virtual connections helps us to know how these are connected. mm. Macro is an instance, or like it is an instance which has like it is a black box, we can say it as. So or an IP, so or a memories, we say it as. Hard macro layout is implemented. Soft macro only HDL is there. We can do in hard macro. We can't do the optimization. In soft macro we can do the optimization. The steps of floor plan. The main steps of floor plan is chip and core aspect ratio definition. Like we used to tell the tool that this is my aspect ratio. Aspect ratio is nothing but I am going to show you the formula. So aspect ratio is the vertical routing resources to horizontal vertical resources, vertical routing height by width. This is the height, this is the width. H divided by W is the aspect ratio. And utilization is the total standard cell area plus macros area divided by total core area occupied by standard cells and macros. So that is the utilization factor. So aspect ratio can be maximum value of 1.25. So it shouldn't be not greater than 1.25. Okay, that is the thing. So after that aspect ratio, initialize the core utilization. How much after placing the macros, how much my core should be utilized? 70% of that or 60% of that? Basically we need to give that below 70%. In my point, like depends upon the technology. For my technologies what I had worked till now, we just mentioned below 70 only. Initialize row configuration and cell orientation. So row configuration is nothing but whether that is R0, R180, R90, based on that we used to give. So uh, like if it is R0, right, it will be placing horizontally only inside the grid. It is going to place in horizontal manner. If it is R90, right, it will be placing VDD here and VSS will be here. So we are just mentioning the orientation, but we are not placing the cells. Keep in mind that I'm just explaining for your understanding sake. So if it is R90, so it will be placing like this. VS and R90 means it will be VDD and VDD and VSS. So this is flipped. So this will be VDD and this will be VDD. So this cell is going to be fixed. This is R90, R180. Sorry, R180. This is, so this is R0. So this is what we need to check out, that providing core to pad IO spacing and pins and pad placement, macro placement by flyline analysis. So macros generally placed using macros flyline analysis. I has just said you right. So how these macros are connected to other macros or other modules based on those lines. So these lines are the virtual lines. So macros placement required also need to be considered. So there are some prerequisites to place the macros that we check out later. Okay. Blockages placement. Blockages are placement blockages and routing blockages, soft blockage, hard blockage, and partial blockage. We will be discussing it later. Okay. Mm, as I said, uh, slanting the slanting of lines. These slants. So if you see here, there are the slant of lines. Uh, Slant of lines denotes a cell orientation. How my standard cells so uh, going to be placed. If it is R0, right, it is going to place like this. So after that, go to IO pad spacing. So this is this we need to mention to the tool, or otherwise we can go give through command also. This we already discussed. And IO placement is generally there is an IO file which is already given. So this is given by the top level guy. And what is different between a pin and a port? Pin is a logical entity and a port is a property of a port. Pin is a logical entity and is a property of a port. So pin pin will be having it for uh, schematics. Here we will be having the ports in layouts. Port is a physical entity, pin is a logical entity. Just keep it in mind. uh, Netlist will have pins and layout will have ports, as I said. And play on, yes, different type of ports: signal ports, core power pads and pins, IO pads, and corner pads, filler pads. These things will be there in the uh, instances. So what are instances? Instances is nothing but every thing which had a different name, like we used to give the instances names, right? Instant names, if this macro will have one instance name, the standard cell will have one instance name, the standard cell will have one instance name, all these IO pads will have one instance name. All these comes under uh, instances. Everything is an instance in my block. If it is having a different name, naming wise it should be different. That's it. Good. So the number of core power pads needed, so this is the formula, we can go through that. So like how many power pads are needed, according to that this thing we can calculate. The dynamic power will be given in the spec file. Number of sites, like 4 sites will be having core voltage, and maximum allowable current to IO pad. So maximum current, macros placement based on how we are placing the macros placement, fly line analysis. So if you see these blue lines, right, these are the fly line analysis. Macro skip out margin, macro skip out margin is nothing but halos. So uh, halos we will discuss it later. Channel calculation, uh, uh, channel calculation, the formula is this thing: pitch of the routing layer plus number of pins to be routed, total available number of metal layers, that is plus buffer spacing. This is for channel calculation. And avoid odd shapes of macros. So why do we avoid odd shapes of macros? As we discussed before, so this should be forming notches. Funnel shaped macros are preferred. Why we are placing funnel shaped macros? So if you take it here, if my macro is placed like this, obviously it is fit to here, fit to this thing, right? Obviously if it is more than this thing, obviously if it is more than here, so it is not going to fit. The macro should be multiples of unit ties, like we can say it as unit ties, or manufacturing grid multiples. That is what. And fix the macros, so that okay, why should we fix the macros? Fixing macros will helps us to while optimization, the tool is going to be uh, remove the macros, or place from one place to another. So that is why we need to fix the macros. After that we need to do the optimization at any stage of time. Macros tips, how we need to place the macros. So macros should be placed at the chip hierarchy, so that core area will not be clustered. So these, if you see here, these are placed at the corners. So this is a wrong floor plan. Irregular shapes, irregular spacings will be forming. So this is the waste of area, right? So we shouldn't waste our area. uh, we need to utilize it properly. Consider the connection to fixed cells. So fixed cells are nothing but other macros, or if there is any other modules, some other fixed modules, like if there is any muxes, big muxes, or anything in advanced like in advanced technology nodes, the orientation we can't change. So that is what we need to take care. Reserve like a reserve room around the macros. So why we need to do that thing? I'll show you this thing. So halos, these halos we need to place. Halo can be moved from one place to another, whereas the blockages cannot move from one place to another. This is used for routing to IOs or any other standard cells. So we need to do those things. Reduce opens as much as possible. So these opens are there, right? We need to reduce these opens. Provide necessary blockages around the macros. So blockages should be placed. I'll show you the blockages. With blockage, this is the blockage. So different types of blockages: hard blockage, soft blockage, partial blockage. So in hard blockage, what is hard blockage? complete standard cells we can't able to place in that blockage. So this is complete hard blockage. Soft blockage is nothing but with some we can place the buffers only. Partial blockage, we I am going to explain it now.